Yesterday I talked about the three main components. So we've got the PLC, that's our hardware, and the actual designation for that is an SLC 5/05, but nobody calls it that. They always call it a SLC 500. So if you talk to someone in industry about an SLC 505, they'll probably know what you're talking about, but they'll go, "Oh, you mean a SLC 500?" So that's what they call it. And PLC programmers, they use a lot of slang, and we're going to get into some of the slang in a minute. Okay, so we've got our PLC hardware, we've got our communication software, and that's what we were messing with a lot yesterday, getting the communication to let us talk to the PLC. It's called RS Links, and the only thing we do with that is we establish communication. Once communication is established, then we just minimize it, we let it keep running, because it's doing stuff for us, but we don't actually interact with it anymore. It's just there and it's running, it's doing the communication for us. And then finally we've got our programming software, RS Logix 500, and that's how we're going to program the PLC. That's our interface with the machine. Okay, so the three main components. The PLC, you got to turn the power on. So make sure all of your PLCs are turned on. Looks like they are. You have to turn on power to the PLC. The communication software, you have to launch it on your computer. And the programming software, you have to launch on the computer. Before you do all that, what's the first thing you need to do when you start work? Reboot. How come?
Saves.
Huh?
Whoever was on it, it saves their settings, you said, or their.
No, it doesn't save anything. You always have to make sure you log into your computer every time so that you can get your computer and PC working.
Close, but not quite. Closer. So when you establish communication between RS Links and the PLC, it makes a very robust connection. So once it, and it's hard to get that connection sometimes, you got to try a few times, but once it makes that connection, it doesn't want to let go. It says, okay, I got it, I'm not letting go. And when your computer goes to sleep and then you log back in, you're going to log in, it's still going to have that connection, but you can't always see that connection, especially if someone else logs into the computer. The previous connection is still there, and you can't make a new connection because it can only have one connection. So the best thing to do is always reboot your computer before you get started. There's two main types of communication that we use with PLCs. One is serial communication, or USB, and the other is Ethernet. Which one is more powerful? Ethernet. Ethernet is by far the most powerful. Why are we not using it this week?
Serial and analog is more common?
Maybe more common. I'm not sure if it's more common for sure.
Did you get the basics?
The basics, it's the easiest. So it's not the most powerful, but it's the easiest. And even though it's a little bit finicky to get running or get connected, once you have it connected, it's very reliable. So it works really well, and it's the easiest. It's not the most powerful. So once you get more advanced into doing automation and doing programming and controls, you're probably not going to use it very much. It's kind of the backup sort of, if you can't get things working, we resort back to serial communication and get us back into using the Ethernet. Okay, so it's the basics. All right, I'm going to draw a short picture, a quick picture of the lab, of the ceiling. So there's our lab, And there's the entry door, and we got a door over here somewhere, right? It swings out. And we've got two switches over by the door, over there. And we've got a bunch of fluorescent lights. So I'm just going to draw some of them. Switch number 1 is connected to, it's like connected to this guy, and this guy, and this guy, and this guy. And switch number 2 is connected to this guy, and this one, and this one, and this one. Makes no sense, right? Flip switch 1 for me, could you please?
Oh, wow.
So which lights went off? It's kind of like I drew, right? It's like couple there, couple there, couple there. Now flip to the other set. Again, it's like random all over the place. So a problem I have in this lab is if I put my camera down low, it gets a glare off the screen and you can't see anything on the camera. That's why I put this GoPro up on the stand, up on the table, so it can have a sharp down angle to avoid the glare. So I can't get a good solution with the switches, right? I flip one, flip them again, could you? So no matter what, I can't control these lights the way I want to control them because those two switches are hardwired to all of these lights. It's the old electrician way of doing it. You're an electrician, right? Who else is an electrician or electrical experience? Few people? So, actually, turn both on though, thanks. So the problem we have with old-fashioned, and shouldn't really call it old-fashioned, but I'm going to call it old-fashioned, with traditional electrical wiring is I can't change the way it's done. I can't reprogram these switches and these lights to turn on and off the ones I want to do because everything is just hardwired. And it's still following logic, right? So I can say, someone needs to mute their microphone. Let me just see. From here. There we go. So it follows logic. You can say if I turn this switch on, then this, and this will turn on. But it's not programmable logic. It's logical control, but it's not programmable logic control. So let's draw something a little different. Here's my switch 1, and here's my light 1. And now I'm going to draw switch 1 again. And there's my light number 2. So I've got switch 1 twice, and I've got 2 different lights. So that means if I turn on switch 1, both of these lights are going to turn on. If I don't want to do it anymore like that, I can just change my program and I can just say that I want switch number 2 to turn on that light and switch 1 only turns on this light. So I can change the whole strategy. If these lights were controlled with a programmable logic controller, I could just hook my computer up to it, get communicating between my computer and the PLC, and I could change the program and program any of these lights to go on with either one of those 2 switches. But I don't have that, so I can't reprogram the lights.